Hey everybody, welcome to this next video on measurement notes video on density. And density is simply the relationship between mass and volume. So we've already watched how to find the volume of objects, both solids and liquids, and we've already looked at how to find the mass of an object. So when we combine those two, density is simply a relationship between the two. And well, first of all, what's the equation? Is simply density equals mass divided by volume. So once you find a mass, once you find a volume, you just divide the two, and then you get the density. Now make sure when we label solids, it's got to be like cubic centimeters or cubic meters, whatever you find. Remember, for volume, whatever you find for a solid, whatever you measured it. It could be cubic millimeters. If you measured in millimeters. And for liquids, if you measure in milliliters, it would be like grams per milliliters. If you measure in liters, it might be grams per liter. So let's do a problem. Suppose a substance has a mass of 10 grams, so that's your mass, and a volume of 10 milliliters. Now it's 10 milliliters, so you know it's a liquid. So how do we find a density? Well, it's just mass divided by volume. It's 10 divided by 10 is 1. How would we label it? Well, if the mass is G for grams per milliliter, so it's G/ml, so it'd be 1G/ml. Now, I'm going to show you this, and you're going to see this again in some practice problems. This is a little square that has some very important information in it. And so it says density up here, and you've got the M up above. You got the D times the V. And what this helps you is it helps you find the density of objects. You might say, well, didn't you say density is simply mass divided by volume? But what if you don't get the density? What if I give you the density, say here, and I give you the volume, and I say find the mass? Well, all you do is cover it up. So if I covered up the end, in order to get the mass, if I was missing the mass but I had the other two, all I do is take density times the volume. What if I give you the density and the mass, and I want you to find the volume? Well, just cover up the volume. Volume is mass divided by density. So this helps you solve any of the problems that you have dealing with density. So a lot of times when we think of density, we think of things that float in water, things that don't float. And here are some of the common densities of various objects. And the big one I want you to take a look at is water. Water has a density of 1. And typically anything with a density of less than 1, what do you think? It's going to sink or float? Well, if we look at this, wood, 0.43, does wood typically sink or float? Well, unless it's waterlogged, it will float. How about things like paper? Paper, unless it's waterlogged, will float. So anything less than 1 will float in water. Anything greater than 1 will sink in water. So that's very important to know, that the density of water is 1. Things that are less than it will sink, or less than 1 will float, and things with a density of greater than 1 will sink. A lot of times people say, well, what if something has a density of exactly 1, the same as water? Then a lot of times it depends. Water has something called surface area or surface tension. So if you put it gently in the water, it will probably stay on top. But if you submerge it and push it to the bottom, it will probably stay in the bottom. Now, density is kind of interesting. For example, we know that the density of mercury is 13.6 grams per milliliter. This is a lot higher than the density of water. So if you look at a periodic table, mercury is one of those rare metals that's actually liquid at room temperature. So I wouldn't recommend that you do this, but technically you could lay on liquid mercury. You're not going to sink. Where you can't do this on water, you would sink below the surface. But you can lay, and you can probably even walk on a tank of mercury. Now, mercury is bad for your system, so you wouldn't want to do it, and you wouldn't want to be covered in mercury. It's actually a toxin. One of the other things I want you to know is that density is going to be one of those reoccurring themes that we're going to be talking about all year when it comes to warm air rising, cold air sinking, when it comes to the layers of the earth. Density has a lot to do with it. So what do I expect you to know this year? Know the basic facts about density and be able to find a density of various objects using the formulas. So as always, if you have any questions, please ask. Thanks.